Dear participants, welcome to the training session of economic feasibility of rooftop solar for CNI consumers in Tamil Nadu. I'm Radhika Sri Parvastu. I work in the energy department in Auroville Consulting, and today's webinar will be hosted and presented by Frano De Silva, who is a renewable energy analyst at Auroville Consulting. So this webinar is a part of the bigger project of sustainable energy transformation of Tamil Nadu, also known as SET-TN. It is a consortium of Auroville Consulting, Citizen, Consumer and Civic Action Group, and the World Resources Institute of India. So without any further ado, I will hand it over to my colleague Frano, and we can begin the training session. Thank you.
Hello everyone, and welcome to this webinar training session. Thank you, Radhika, for the introduction. In this webinar, to begin with, we would like to take you through a journey of designing an economically feasible rooftop solar system. We would also introduce the web tool Solsavi. We would conduct demo scenarios to get familiar with the working of the tool. We will further discuss the results and finally end with the question and answer session. During the webinar, we would have some interactive sessions where we would take polls and ask multiple choice questions to the participants. The polls and the multiple choice questions will be featured from the Zoom platform, and so we will not change any other platforms while this webinar. Please hold your queries until the Q&A session at the end. I would like to inform the participants that the session is recorded for internal use. So before we begin this journey, we would like to define and we would like to understand how we could design an economically feasible rooftop solar system. To be able to design a rooftop solar system, we would first have to understand our boundary conditions. And these boundary conditions are provided to us by the solar energy policies and the related regulations. As we are going to talk about the commercial and industrial users in Tamil Nadu, the solar energy policy for Tamil Nadu and the regulations for the solar energy policies will be discussed briefly. Initially, the Solar Energy Policy 2019 was released to encourage the adoption of rooftop solar systems, and additionally, generic tariff order was released in the later half of 2021 for the grid integrated solar systems. And in this order, the net metering mechanism was introduced for all domestic consumers, the net feed-in mechanism for all HT and LT consumers, while gross metering was introduced for HT consumers with system larger than 150 kilowatt. The network charges were introduced in this generic tariff order. Also, the premium charges for export to grid during peak hours was also introduced. The tariff revision for feed-in mechanisms is as shown in the table, and it can be seen that the feed-in tariff changes with the voltage categories as well as the PV capacity. Please note that the maximum PV capacity that can be installed is 999 kilowatts capacity. So to further explain how we can understand our consumption from the boundary conditions that have already been laid out, to realize how we can take this consumption for our connection, we can take references of the electricity bill that is provided to us by the Tamil Nadu Electricity Department. In this slide, we have shown you an electricity bill for the HT connection. And as you can see, the bill shows the application period, the sanction load of the connection, the tariff category under which the connection is applied for, the tariff rate under that category, the consumption units for the period of consumption, and in this case it is monthly. While if you know, for domestic consumers in Tamil Nadu, the billing cycle is bi-monthly billing cycle. Hence, we would also have to be aware of how the billing cycle, or how often the billing cycle for that connection or for that consumer category is. Finally, the consumption is then taken with the applicable tariff rate for that category, and we get a final electricity bill. To explain how we generate a consumption profile, let us assume that we have a monthly average of 1000 units that is consumed under one connection. We make this monthly consumption into a daily average by dividing by number of days, and we have a daily average of 32.25 kilowatt hours, that is the units of electricity consumption. At this point, I would like to ask the participants through poll that in the Zoom feature, and the question is, out of the two consumption profile, the profile A and the profile B, which consumption profile is a close approximation for a domestic consumer? Is option A a better representative of a domestic consumer, or option B is a better representative of domestic consumer? Please give your answers in the poll during the session. To maybe join a story with the consumption profiles, let's say that in option 1, the user or the person occupying the connection or having the daily average consumption of 32.25 kilowatt units has a consumption profile where he consumes consistently an average of 1.4 units every hour. Let me end the poll and share the results with you before explaining the consumption profiles. As you can see, the participants have answered that the option B, consumption profile, better represents the poll, or better represents the load profile of a domestic consumer. Continuing with the explanation, let's say in the option A, the user is continuously consuming around 1.4 units at an hour for 24 hours. And this could mean that maybe the user has a fridge running continuously in the house. Maybe the user has a geyser running continuously in the house, and this runs for 24 hours. Similarly, if we notice at the consumption profile option B, here the distinction is quite clear when we would say, or if we would say, that the person occupying this area wakes up at 6 o'clock in the morning, makes his or her coffee, uses geyser in the morning to maybe have a shower, uses the washing machine at this time so that the person can dry the clothes or before leaving the house, and maybe leaves the house at 10 o'clock and then has a continuous consumption of base load between 10 o'clock to 6 o'clock in the evening. And at 6 o'clock, the person returns back from the office, from the school, or from any other commitment that the person had, and continues maybe cooks the dinner at the evening, maybe switches on the TV, or has a consumption pattern which contributes to a lower peak between 6 p.m. to 10 p.m. and further retires for the day. As you can see, this consumption profile has a better explanation and a better representation of a domestic consumer. Hence, moving forward with this consumption profile, how do we generate this consumption profile in our web tool? Well, to explain it briefly, we take the monthly average or the consumption provided by the user. We convert that monthly average consumption or the annual consumption to a daily average, and further this daily average is then allocated for each hour in a day. And to do this allocation, we divide the day, that is 24 hours, into 4 time sections. And the time sections are as mentioned in the table, that is from 6 a.m. to 10 a.m., from 6 a.m. From 10 a.m. to 6 p.m., from 6 p.m. to 10 p.m., and finally from 10 p.m. to 6 a.m. To generate this consumption profile in the web tool, we use the percentage of consumption, which should amount to 100%. To have an accurate representation was 40% of the consumption in between 6 a.m. to 10 a.m. and the remaining time sections will have a consumption of 20% each. When a solar panel is installed for this load profile or for this consumption profile, as we can see from the graph, the red line indicates the total solar energy generated from the solar panel. That is, the area under this curve, under the red curve, is the total solar energy that is generated in 24 hours from the installed PV system or the solar system. Under this curve, whatever load or whatever consumption profile that falls under this curve is then managed by the solar system installed. That is represented by the green area shown under the curve. The orange area represents the amount of solar energy that is exported to grid after satisfying the load requirement at the location. So, as you can see from the table as well, if the daily average in this case was 32.25, 22.55 kilowatt hours in a day, which amounts to 70% of the daily average, is given by grid, or rather is imported by the grid, while 30% of the load or the consumption is supplied by the solar system installed, and 50% of the solar energy that is being generated by your solar system in this case is exported to grid. Now that we realize that there is a certain amount of energy that is being generated by solar being self-consumed at the location, also the excess or the surplus energy is being exported to grid after satisfying the load requirements. But such a complex accounting would then require us to understand how the accounting or the energy accounting for such a system will take place. And from our boundary conditions, or rather from the solar policies and the regulations, we have realized that we have 3 metering mechanisms that are available for the consumers in Tamil Nadu. And to slowly explain these three metering mechanisms, we begin with the net feed-in mechanism or the net feed-in arrangement. As you can see in the net feed-in arrangement, we have a unique bidirectional meter connected between the grid and the location. This bidirectional meter records the units that have been supplied from grid to the house, and also records the generation and exported units that are exported to the grid from the solar system. So my question to the participants now is, in net feed-in arrangement, the net amount to be paid is difference between amount to be paid for consumption from grid and revenue generated from grid. If participants think this statement is true, please indicate true in the polls that have been recently launched. Or if the participant thinks that no, this accounting system varies and the statement is not true, please indicate by answering the option false in the poll. And further, to give a little bit more explanation on the net feed-in mechanism, the bidirectional meter records the units that have been imported by the grid and also records the units that are generated by solar energy system and exported to grid. The self-consumption that takes place in this metering mechanism is not recorded in this meter. Thank you for answering the polls, and I shall end the poll now and share the results with you. And as you can see, the participants have answered that it is true that the net amount to be paid is the difference between amount to be paid for consumption from grid and revenue generated from export to grid. Thank you for answering the questions. And moving further to explain a little bit on the different solar metering arrangements that are available. Then, as you can see, the net metering and the net feed-in mechanisms both have the same arrangement of the meter between the grid as well as your consumption location. However, the energy accounting for these two metering mechanisms, that is the net metering and the net feed-in mechanisms, differ in how they are accounted for. For example, in net metering, the energy accounting is based on the units that have been recorded in the bidirectional meter, that is the kilowatt hours or the consumption of the house or the location. While in net feed-in, the energy accounting of the exported energy takes place at a fixed tariff set by the Tamil Nadu Electricity Regulatory Commission. In gross metering, the gross solar energy that is generated from your solar system is directly fed into the grid, and the energy accounting for in gross metering is done by calculating all the gross solar energy that is generated with a fixed gross feed-in tariff, again set by the TNERC department. To explain a bit on how the energy accounting takes place for net feed-in and gross metering mechanisms, we take a small example from the previous situation. In this example, we are trying to simulate a accounting scenario for the net feed-in mechanism. As you can see, we have a monthly average of 1,000 units. And after the installation of the solar system, we have a grid contribution of 700 units, that is 70% of the load is satisfied or is supplied by the grid electricity, that is 700 units. While the solar system or the installed solar system satisfies 30% of your load requirement, that is by supplying 300 units of generation of solar energy. And the remaining 300 units that is generated from the solar energy is then exported to grid because they are excess to the load requirements. Assuming that we are doing the energy accounting for the industrial LT category, the grid tariff for industrial LT category in Tamil Nadu is 6.35 rupees per kilowatt hour. In the table below, we have the business as usual calculation, which is the grid supplied units multiplied by the grid tariff. That is, if we take the grid supplied units as 1,000 and the grid tariff for industrial LT according to Tamil Nadu, we get a bill amount or a bill total of 6,350 rupees. While if we employ the net feed-in mechanism after installing a rooftop solar system, we have the calculation as shown in the slide, where the grid supply units, that is 700 units, is multiplied by the grid tariff, that is 6.35. Further, the exported units, that is 300 units exported to grid, will be charged at the net feed-in tariff decided by TNERC at 3.37 rupees per kilowatt. finally giving us a bill total of 3,434 rupees. To simulate a gross metering scenario, let us check how a gross metering energy accounting would vary from the net feed-in energy accounting. In gross metering, as mentioned before, all the gross generation, that is entire solar energy generation from your solar system, is directly exported to grid, while your load requirements are completely covered by the grid electricity supply. And to do the energy accounting for under gross metering mechanism, as you can see from the formula given in the second column, the grid supply units are multiplied by the grid tariff, that is your monthly average, that or the grid to load is supplied at 6.35 rupees. And further, the total amount that is exported under gross metering, in this case that is 600 units, is multiplied by the appropriate gross feed-in value, that is 3.1 rupees per kilowatt hour, gives us a total bill of 4,490 rupees. Additionally to this, under the recent regulations, that is the tariff order, generic tariff order released in the latter half of 2021, the network charges also was introduced in that regulation. And to further explain a bit about network charges, network charges explained briefly is the grid support charges for the solar energy generation by your system. And the network charges are levied on the gross generation of your solar energy system. That is, it would be applied to both your self-consumption as well as your export to grid units. The network charges is applicable for units generated by the grid interactive solar system under net metering and net feed-in mechanism only. And for CNI consumers, as shown in the table, the network charges are defined separately for the voltage type as well as metering mechanisms. And as represented in the table, there is no charge or no network charge levied for the gross metering mechanism in Tamil Nadu. Here, I would also like to inform that Tamil Nadu is the only state in India right now that is applying network charges in their energy accounting procedure. So to include network charges in our accounting, what we take, as this is an industrial LT case, we take the network charge that is applicable for the net feed-in LT category, that is 1.27 rupees per kilowatt hour. And as from the table, we can see that the network charge is added for the gross generation of solar energy. If you would remember that in net feed-in, 50% of the energy was taken to satisfy the consumption pattern of the user, and 50% was exported to grid. However, the network charge is calculated on the gross generation of your solar energy system. Hence, while calculating network charge, we have to take into consideration the whole generation from your system and apply that to our bill till now. Hence, doing so under net feed-in mechanism, we pay a total amount of 4,196 rupees as compared to a business as usual case where we would pay 6,350 rupees for a monthly consumption of 1,000 units. Further, for gross metering, as you can see, the network charges are not applied for the solar generation in the gross metering, and the bill amount remains the same as 4,490 rupees for the billing cycle. Now, as we have understood how we need, as we have understood the boundary conditions that are defined by the available net metering mechanisms, as well as the feed-in tariffs set by TNERC, we also have realized that taking into consideration our consumption profile is quite important, and how metering mechanisms are impacting our energy accounting and our bill calculation depending on the load profile that we have. So to further, I would like to introduce what optimization criteria we have taken in consideration for the web tool to provide you with an optimized system capacity for your consumption profile and for your policy regulations in your location. For now, we have the database set for Tamil Nadu, and hence only the policy details and regulations for Tamil Nadu is applicable in the tool at the moment. With the optimization criteria, the aim of the optimization is to maximize our avoided costs, maximize our savings, and minimize the payback period for our investment. The important parameters to consider while optimizing is the amount of self-consumption. That is, how much from the solar system are we going to self-consume and satisfy our load. The export to grid aspect also will play an important factor in designing the optimized system capacity for your load consumption. While we would also like to keep an eye on, or rather have the input from grid as an important parameter too, to gauge a economically feasible solar system design for our consumption. To further explain a bit more on the avoided costs, please make a note of this graph where we show on the x-axis the generation costs in the x-axis and the years or the period in the y-axis. We have two representations here. One is the rooftop solar, where we find out the rooftop solar generation cost to be between 4 rupees and 5 rupees per kilowatt, while we compare the generation cost for the rooftop solar with the HT industrial tariff, that is 6.35 rupees per kilowatt hour. And if we are assuming a future where the HT industrial tariff will increase over a period of time in the coming years, following the trend it has followed in the past. While rooftop solar or generation cost from rooftop solar is predicted to be fairly consistent between 4 rupees to 5 rupees per kilowatt hour for the coming few years. So this, as you can see from the graph in the slide, the difference of cost of generation in 2021 itself provides a potential saving or a potential for avoided costs. While if you see a future situation, let's say example 2029, the difference in the cost of generation increases owing to the yearly escalation of the HT industrial tariff, and if solar rooftop is adopted, the area under these two curves is the potential savings that can be achieved by installation of the rooftop solar, or the avoided costs that can be achieved by installation of rooftop solar with respect to the generation costs and the grid tariff that is being allocated by TNERC. To move further and define the financials of our system, we have considered the benchmark cost set by MNRE, that is the Ministry of New and Renewable Energy, which was released in 27th October 2021, and the values are shown in the table, which are bifurcated, or rather which are allocated a PV capacity range. If the PV capacity range is below 1 kilowatt, the benchmark cost suggests that the per kilowatt cost would be 46,923, which includes your inverter cost as well as other balance of system cost. And this cost varies as per the PV range. And you can see with the increase of PV capacity, the per kilowatt cost seems to reduce. Now, these benchmark costs were released by the MNRE, and these costs can be taken as an initial suggestion to design your rooftop solar systems. However, these are just suggestive costs for your PV capacities, and you could take in consideration the recent financial cost for the PV capacity or an alternative cost which seems more appropriate for your application. Further, for a solar plus battery system, the battery costs and the inverter costs have been taken from research. Here, the battery costs have been bifurcated for the technology that has been offered in the web tool, that is for advanced lead acid and for lithium ion battery capacity. At this point, we have understood about the boundary conditions of our system, where we have realized that available metering mechanisms, the feed-in tariffs that act as a boundary condition for the designing of our solar rooftop system. We have gone through a process where we have defined our consumption profile. We have understood how to allocate consumption profile in the web tool as well. And further, we have also learned a little bit about the energy accounting that is done under net feed-in and under gross metering mechanism. We also talk about financials, and the next step would be to find out the motivation of the user to install a rooftop solar capacity. Hence, I would like to pose a question here to the participants. And this question is to find out the motivation of the user to consider installing a rooftop solar system. The options provided are savings on electricity bills, the lower emissions, or legal regulations. What could be the motivation for you as a user to install a rooftop solar system? Thank you for answering the poll. I will end the poll and share some results which show us that we have a lot of participants ensuring that they want savings from electricity bills. That is 100% of the participants would like to install the solar system to get benefits from the savings on electricity bills, as well as we have a participant who would like to install the solar system for an additional benefit of lowering the emissions from generation of electricity. So we agree with you when you say that you have the financial benefits, while I present you three main reasons that we could consider rooftop solar for our installation. The first one could be the legal requirement or a building code regulation. The TNCDB rules says that it requires installation of solar energy system in high-rise and non-high-rise buildings exceeding 16 dwelling units and 300 square meter of commercial building. This would mean that a commercial building would need to have 1/3 of their rooftop area installed with solar energy systems. It could also offer an environmental advantage by providing a renewable energy source that eventually leads to lower emissions due to generation of electricity. We also have a financial savings here, which is a long-term savings. and an increase in property value when we install solar panels, while sustainability also adds to the selling value with the installation of solar panels. To take you through the decision-making process for installation of solar panels, we start with the conception and the feasibility check, where the concept is brought into an inception, the concept is clear, and the feasibility of this project is checked. Further, the design aspects and planning takes place, and finally the installation is done. After you install this solar system, you will have to operate and maintain this system. Now, during the process, when we do a feasibility check, we are ensuring that the system we have is an accurate or an optimum system for our requirement. And while this is done by an experienced engineer, usually this would require an alternate opinion to have a comparison, which would also require a detailed generation pattern from the assumed or the estimated solar capacity, the potential savings and the investment requirements that will be needed to install this rooftop solar system. And additionally, these have to be done quickly. This is where we introduce the tool Solsavi. And we try to see and fill the gap here where we could provide the engineer with an alternate opinion. We could provide the engineer with some details of how this solar system would behave after installation, and also give an idea about the potential savings that could be incurred for 25 years and the investment required to have the solar system put in place. At this point, I would again like to ask the participants to answer through poll if they were able to simulate the activity that was mentioned in the registration mail, and the activity was to take your electricity bill and use the rooftop solar tool to estimate your savings on that electricity bill. Please indicate yes if you were able to do this simulation and if you were able to get some results from this simulation. Thank you, participants, for giving us the poll, and I will just end the poll to share results with you. And our participants, 100% of our participants have done the simulation and have used the tool before this webinar. So, to introduce the tool, we would say that Solsavi, your rooftop calculator, has been updated with the recent tariffs and also the policy regulations for the location, and in this case Tamil Nadu, as we have only the database for Tamil Nadu fed into the Solsavi application. The Solsavi application also provides a detailed consumption pattern, so you can define your detailed consumption pattern for 24 hours, or you could further give more details such as a monthly consumption from January to December to devise a detailed consumption pattern of your choice. Further, the Solsavi application also gives us an opportunity to include battery storage in our simulation using an internal optimizer to give us an optimum solar capacity and battery capacity, or we use the customized option where we could use our desired battery capacity into the simulation. The financial outputs that we get from the Solsavi is in terms of potential savings, the payback period, and return of investment. The analysis done is for 25 years, and it's the same as the lifetime of a PV solar panel. Where Solsavi improves on from the existing tool is that Solsavi gives us an updated tariff and policy regulations. While most of the tools do not facilitate or do not accommodate battery storage, Solsavi tries to facilitate battery storage into its calculation depending on the requirement of the user. And most of the online tools are developed by solar developers, which could eventually lead to a conflict of interests. Further, to be able to help us design the rooftop solar system in the Solsavi Web Tool app, we have decided to go with two scenarios or two demo scenarios. The first scenario I will simulate on my own and give you instructions and explain the results generated in a little more detail. While the second scenario, we could do the simulation on our simultaneously, where you would follow me and do the simulation on your desktop. So for the first simulation, I would request you to not do the simulation with me, while we could do the simulation together for the scenario 2 case. In the first demo scenario, we are simulating an industrial warehouse with a sanctioned load of 120 kilowatt and a solar plus battery case under net feed-in mechanism. The location selected is Chennai, voltage type HT, with an average consumption of 20,000 units per month. And we define the pattern where we see the peak consumption between 10 a.m. to 6 p.m. of 40%, and we try and run the optimize option here. To show you the simulation on the Solsavi site, I will now stop sharing my screen and share you the desktop where I will be doing the simulation. I hope the participants can see my screen now, and this is the landing page of the Solsavi website. The landing page includes a small description about the Solsavi website, also a video description where we give us idea or indication of how you could do the calculation in using the solar rooftop tool, that is the Solsavi. We have a contact form for you to contact us and get in touch with any queries that you have regarding the app, and also some useful links from Auroville Consulting. To go further on the simulation, we have to press the Get Started button, which takes us to the first page of the Solsavi web tool, that is the demographic page. At the demographic page, we have to define our location by giving the PIN code. We have to define our consumer type, and as well as define the voltage category that we are simulating the situation or the scenario for. As mentioned, the PIN code is for Chennai, and we put the Chennai PIN code. Please wait until the area or the description of area is generated, because this allows us to fetch weather information for that particular location. And if until this information is fed in, we cannot proceed further, and hence please wait until the location description is shown after entering the PIN code. Further, we move to define a consumer type, and in this category we define the industrial consumer type with an HT connection. Moving further, please press the next button to move to the next page. Hence, we land on the policy page. The policy page gives us details about what metering mechanisms are available and what technology is available for us. In the sample scenario, we take the net feed-in technology as our scenario mechanism. And if you would like to know a little bit more on how net feed-in works or how other categories work, we could hover over the I button and read the information that is given about the particular topic. Further, to define the technology, we select a solar plus battery technology in this case. Moving to the next page to define our consumption. As mentioned, our sanction load will be 120 kilowatt with an average monthly consumption of 20,000 units and a load distribution of a peak between 10 to 6 p.m., a 30% contribution between 6 p.m. to 10 p.m., a 20% contribution in the morning 6 a.m. to 10, and a 10% contribution in the last time section. Please ensure that the sum of the percentages for allocation of distribution or load distribution must be 100%. Else you will have this error which will prompt you to revert back to a sum of 100% before proceeding to the next step. In the consumption pattern, we also are able to define a separate consumption pattern for the weekend as compared to for weekday. For this simulation, we would say that we do not define a different consumption pattern for weekend and hence select no. Moving further to the technical page, here we must have the selection of the battery technology and the dispatch strategy that we would suggest the charging and the discharging for our battery system. For this case, we take a battery technology of lithium ion, and as you see on the selection of battery, the system financials are populated on its own, taking references from the benchmark cost as well as including the battery and inverter cost under solar plus battery system. With the change of battery, you can see the change in the battery systems, but we have considered lithium ion for this simulation and we keep lithium ion as select. For dispatch strategy, we select the auto dispatch strategy, or we could define a charging time and a discharging time in the manual dispatch strategy. For this simulation, we go or move forward with the auto category. Moving further to the next stage, we have two options, optimize and customize option. The optimize option goes to an internal optimizer and allows us to optimize our solar capacity and battery capacity based on financials as well as the consumption pattern. For this case, we would select an optimize option and see what results we get. The simulation usually takes around 30 seconds to give us results. Please be patient during this time to give us results, and in case if the simulation has hit a roadblock or hit an error, you will get a pop-up message called something went wrong. In this case, please click the Solsavi button on your top left and it will refresh and take you to the first page. We also have the FAQ buttons to check the frequently asked questions, and you could take references of the FAQs to see if it could help clear some doubt. As you can see from this, our annual savings are shown in the negative for the first year, but we have a payback of 9 years for this system under our industrial LT category. The total system cost would come up to 85 lakhs, and we have a return on investment negative. Usually a negative return on investment would indicate a not so good investment. However, if you could see at the magnitude of the return on investment, the magnitude also indicates that we have an area of improvement that could make this investment profitable. We have the solar system capacity suggested to us at 120. That is the maximum possible solar capacity, because our maximum capacity is restricted by our sanction load. If you remember, the sanction load was 120 and The optimized system suggests a maximum solar capacity of 120 with a battery capacity of 168 kilowatt hours. We find the daily solar generation from our solar system and the avoided emissions after installation of this solar system. We can go to detailed report and we can find more details and more analysis on our solar system or our suggested solar system. Under your input parameters, you will find the input parameters that you have entered during the simulation. The average monthly is converted into an annual electrical consumption, and the annual bill payable is shown under the business as usual case, while the selection of metering mechanism is net feed in for your proposed solar system. On the right, we have a typical load profile which shows us that between 6 in the morning till 6 in the evening, we have a steady load in the premises. After 6 in the evening until 10 in the night, we have a peak consumption during that period, and further falling down to a base load, or rather minimum load, during the VRs of the day. We could also select a period of 1 week to display the range of values over the week. Hence, this graph could be used to see the difference between a day-to-day load profile. We come to the midsection of the results, where we find the results for the financial analysis for our system. As you can see on your left top, we find the details of the selected solar system, the suggestion for the inverter size, the battery capacity, the selected battery technology, and the shade-free space required for the installation of the suggested solar system. The assumption taken for the area is that 1 kilowatt of solar system would require 10 meters square of a shadow-free area to be installed. These solar system costs are given on the right of the page, where we have the total cost of the total investment cost of the system. Further, coming down on the left, we have the payback years coming up to 8.72 with a return on investment, further showing us the savings in 1 year and savings in 25 years. This savings in 1 year and savings in 25 years also include the loan interest amount as well as principal amount payments. Also, the O&M expenses that are carried out during the lifetime. On the right, you have your electricity bill comparison, and this comparison is from year 1 till year 25. And as we can see, the electricity bill with and without system comparison for 25 years, the potential savings is the area between these curves. That is the avoided savings that have been occurred after installation of the solar system. For the final section in the results page or the detailed results page, we can see on the right of how our consumption profile has been sourced from the solar system or the grid. In this case, 45% of the load has been satisfied, or the consumption has been satisfied from the solar installation. That is, from 45% of the load is covered by the solar energy system, and 35% of the load is covered from the grid. As you can see, if you hover over the legend, you can see the specific areas that are covered from specific energy sources. This area shown in the chart on the right shows us how much load has been covered from grid, And this shows us how much load has been covered from system. And as you can see, battery contributes to 20% of the load. Hence, you could see that the battery contributes a little bit in the morning and after sunshine hours for our installation. While 30% of the total solar energy that is generated is exported to grid. In this graph, you could find out at the consumption pattern and the contribution pattern from the solar system for any particular day in the year. Let's say we go to August and we see on the August 20th what is our consumption and generation pattern. Or if we want to go at the end of the year and select a day at the end of the year and see the consumption pattern, it is possible. To have the user realize the assumptions that have been presented in, or assumptions that have been taken into consideration for our simulation, the user or the participant can find the assumptions at the bottom of this detailed report page and click the option click here, which will take you to the next page showing the assumptions that have been considered for the 25-year analysis done under in Solsavi Web 2. There is also an option for the user to export this PDF, to export this results in the form of PDF and display or save the results whenever possible. I'm going to stop my screen now and explain the second demo scenario where you would accompany me in the simulation of the analysis. At this point, I would request the users to please go to www.solsavi.in in your web browser and confirm through message in the chat that you have reached the landing page. Once you give me the confirmation, I will stop sharing the screen and we can start simulating the scenario 2. For scenario 2, we will have a commercial building, or we will simulate a scenario for commercial building. We will have a scenario for commercial building and we will check with a sanction load of 55 kilowatt, designing a scenario for solar only system under net feed-in mechanism.
Mr. Manoj Suburam, can you please confirm if you can open the Solsavi website? Thank you. Frano, I think now you can continue with the simulation.
Thank you, Radhika. And thank you, participants, for confirming you have reached the landing page. To give a brief before we start the simulation, as I was mentioning in scenario 2, we will simulate a commercial building with a sanction load of 55 kilowatt under a solar only system and under the net feed-in mechanism for the voltage type LT with an average monthly consumption of 8,000 units. I'm going to stop my screen here and share the screen with the simulation. I hope my screen is visible to everyone.
Yes, Fanu, it is.
Thank you, Radhika. Moving further to simulate the second scenario, please press the Get Started button, which will take you to the demographic page. At the demographic page, first we define our location. And as mentioned earlier, the location was decided to be Chennai. Please enter 60001 and wait for the description to load. Once the description has loaded, please go to the next selection criteria, that is the select consumer type, and select the commercial category under the consumer type. Under the voltage category, we will select the LT voltage category and press the next button that is placed in the bottom of the page to move to the policy page and define our policies. For this, we have selected the net feed-in mechanism and a solar only technology case. So we select the solar only case and press next to simulate to further define the consumption pattern. The sanction load that has been mentioned for the demo scenario 2 was 55 kilowatt with a monthly average of 8,000 units. Another option to define your electrical consumption would be to select the month-wise option, where the user will have to install the units consumed in each month over the year. This would provide us with maybe a seasonal variation in your consumption and could add a better nuance to design a more efficient or economically feasible rooftop solar system. I see Mr. Deepak Kumar has raised his hand, and I would ask Mr. Deepak Kumar to maybe hold his question till the end of the simulation into the question answer session. Moving further, to define our load consumption or the percentage of the consumption in the different time sections, we have decided we have given 40% of the consumption to be allocated between 10 a.m. to 6 p.m., 20% between 6 a.m. to 10 a.m., 30% between 6 p.m. to 10 p.m., and a meager 10% in the wee hours of the night for that location. In this simulation, we would like to define the weekend consumption different to the weekday consumption, assuming that this commercial property or facility has a higher weekend consumption as compared to weekday. We would give the percentage of consumption as similar to weekday, but we define the relative consumption pattern to be 25% more as compared to weekday. If you select a minus 25%, this indicates that you have a load profile of 25% lower than your weekday on your weekend. And as I have defined here 25, this would mean that it is 25% above your weekday consumption. Thank you, Mr. Deepak. I've just seen your chat and maybe I can explain you briefly on the policy part. With the selection of the location as well as the consumer type and the voltage category, you will be assigned a metering mechanism that is applicable for your consumer type under that voltage category in the location that you have selected. For example, if in Tamil Nadu, if I select commercial and I select an HT voltage category, I would have an additional option of using gross metering. While For this scenario, as we have taken an LT category, we have only net feed-in as our applicable metering mechanism. And further, as for this scenario, we select a solar only case, we select the solar only option here. I hope this solves your question or query. Moving further, to define a consumption pattern and the weekend consumption pattern, we move forward to our technical details. As it is a solar system and mentioned before, the technical financials details are taken from the Ministry of New Renewable Energy benchmark cost released in the latter half of 2021. This are suggestive cost for your solar panel per unit, that is per kilowatt. However, these could vary according to your location, depending on what balance of systems you select or what type of installations you select. And this can be modified as per your requirement. For this case, we put a meager 1,000 rupees subsidy that could be allocated under various sectors or sections in Tamil Nadu. To proceed to the run page, press the next button. And for this simulation, we do the customized run where the user defines their solar capacity. And in this case, as we have the sanction load mentioned as 55 kilowatt, and with the policy regulation telling us that we cannot install a solar capacity above our sanction load, we take the maximum possible solar system that can be installed under this case, that is 55 kilowatt, matching our sanction load. Press the run calculator option and wait for your results to be generated. As you can see from the results, the selected system offers us a savings of 1,30,000 in the first year with a payback of 4 years and a system cost of 21 lakh, that the total installment cost of 21 lakhs. The return on investment over a period of 25 years is 2.62, which is a positive value indicating a good investment, and the magnitude offers us a potential saving or more potential saving in indication. The solar capacity mentioned by the user in the customized case is reflected as 55 kilowatt. With no battery selection, we have no value for the battery capacity, and a daily generation profile from the selected system is offered along with the avoided emissions as compared to the case where the solar system is not installed. You have the detailed report, and you can further delve into the further details that are shared as the load profile that is generated and the period between the load profile, as to show you the difference between the weekday and weekend. As you can see, in the weekday, our consumption profile seems to be lesser than the weekend. And as we have mentioned earlier, we provided the weekend consumption to be 25% higher than the weekday. And it is reflected in your load profile when you select either a weekend day or you select a range of day between the weekend and a weekday, showing us the 25% difference. We further can see the comparison of electricity bill with system and without system, and how much our potential savings are for 25 years, which is represented in the left under 25 years saving. From this system, we see that 46% of the load is covered by the solar system, or rather supplied by the solar system, while 53% of the load is supplied by the grid electricity. As noticed from the legends, you could see what portion has been supplied from the grid for your load, as well as what portion has been supplied from the system, installed system, and what portion of the solar energy that is generated is exported to grid. Here you could see that 41% of the solar energy generated has been exported to grid. Further, the PDF can be downloaded and saved as a document for further references or comparison with another case. Another option that is provided in Solsavi, the web tool, is for you to do a revised calculation, where you could use this button and it takes you to the first page, and you could recalculate and check how or what could make a difference. For example, let's say that we have decided that we will not have a weekend consumption 25% higher than weekday, and we say that our weekend consumption is the same as a weekday. And to find out what impact it has on our saving, we further proceed and customize to the maximum capacity of our sanction load and run and see how we could obtain a different result. At this point, I would like to ask the participant if they were able to simulate the scenario along with me during the simulation. Please, you can respond in the chat and confirm that that you were able to follow the simulation. Thank you, Deepak, for confirming that you were able to follow. I will stop presenting the website now and share the slides with you. To close this session. Further, we move into the Q&A session, and we would invite questions from participants in this session through the chat option. So please post your question on the chat so we could take them and answer them as clearly as possible. You could unmute yourself and you could ask the question as well. That is not an issue, as we have less participants today. Mr. Deepak, Mr. Manoj, would you like to pose some question to the panelists, the host and the co-host?
Yeah, hi, Mr. Franco.
Hello, Mr. Deepak.
Yeah, hi, how are you?
I'm doing well. How are you? Hope all is good with you as well.
Yeah, everything is good. And thank you for this presentation. It's really useful and it widens up a lot of things. And like, is there like, can we get somewhat kind of like user manual kind of things, like a brochure or something, how to use this, like instead of explaining personally, instead of explaining to persons, like if we use it, if we give it to friends, it will be useful for them as well.
Okay, so you mean to say maybe we could share you a brochure or steps to use the tool?
Yeah, I think there are only 5 steps, like maybe in a single page we can.
Okay, that's a very nice suggestion, Mr. Deepak. And maybe we work on making a one pager where we could give simple instructions for new users to follow, or we could maybe make a demo session, a demo video session where we could show how the tool works, and that could be easy for the new user to follow. But thank you for your suggestion, and we would take this into consideration and have some material ready for new users.
Yeah, thank you very much.
Thank you, Mr. Deepak, for your question.
Thank you very much for the presentation too. Thank you.
Thank you. Also, I would like to inform the participants that the video is recorded and we'll be putting it. We will put it online and maybe share the link with you. Mr. Manoj, would you like to answer the question as well?
Yes, sir. I have a doubt whether everywhere we are having that possibility to export that power generation to grid, whether the facility is available everywhere in Tamil Nadu or.
If you mean the interconnection to grid.
Yes, yes, sir.
Yeah, yes, and I would say that when you would like to apply for the metering mechanism, you will have to apply to the TNEB for the connection, and TNEB will facilitate this option for you at all locations in Tamil Nadu. I hope that is clear that yes, you will have the opportunity to export from any location in Tamil Nadu if you adopt a metering mechanism.
Well, where can I get the details, exact details from the rules and regulations to be followed if I want to?
So if you would like, if you're interested to know more about it, maybe you could check out the solar energy policy and the tariff and the recent regulation that has been released, that is the tariff order regulation. Maybe we could share some material with you so that you could have some information on how you can proceed further for finding out the application procedure.
Oh yes, sir.
Is there anything else that I can help you with, Mr. Manoj?
And regarding selection of solar panels, do you have any suggestion regarding that? I don't know whether it covers the objective of this program.
I understand what you mean, and if I can maybe maybe explain what you mean is that selection of a particular solar panel for installation. How could you do that?
Yes, sir.
Yes. So what we have tried to do in this tool is we have tried to give you the system capacity that you would require for an economically feasible solar system. However, we have refrained ourselves from giving you any names of any particular solar panels that you could use. But I'm sure you will be able to find out multiple suppliers or companies that could give you, because we didn't want to suggest a company or a particular maker, and hence we wanted to just give an optimum size of the solar system and the battery system for your consumption and your policy requirements.
Okay.
Thank you, Mr. Manoj, for the question.
Yes, sir. Thank you, sir.
Any other questions?
Maybe if we don't have any questions now, I would like to get your feedback from the participants by launching few poll questions. Please give us your feedback through answering in the poll. The first question that I would like to, or the first feedback that I would like to know is, were the concepts explained in the webinar clear to the participants? Please indicate your answers in the poll. I'm ending this poll and sharing the results. Thank you for confirming that we were able to explain some concepts clearly to the participants. I have one more poll to launch and to get feedback from you, is that will you use the web tool in the future for your application? We would like to know if you would use this application in the future for your purpose, to know your load or for your business activities. I would end the poll now and share the results. Thank you for confirming that you would use this tool in future. In case while using the tool, you run into difficulties or you would like to ask some queries, please note down the contact information of me and my colleague Radhika, and you could also use the send message option on the Solsavi website landing page at the bottom to send us queries and doubts for the Solsavi web. I would like to bring this webinar to an end now and thank the participants for spending their time, and also the panelists to accompany me during this webinar. Thank you very much, participants, and thank you, panelists.
Thank you everyone for attending. We hope that you find this tool useful and you use it for your business applications. Thank you. Thank you, Frano.
Thank you very much.
Thank you.